So we're live. Good morning, good afternoon, good evening, wherever you are. It's great to have you joining us for this LinkedIn live session, either live or on demand. And today I'm joined by the amazing Tristan Rouillard. It's great to have you on the show, Tristan.
Thank you for having me.
So we've got a lot of exciting topics that I want to go through today, and we're having just a quick chat before we went live, and the kind of angles that we're going to discuss and what we've got to share today. And I always get excited by these conversations, just to go down and see what people's passions are and see what got them into the role that they're in today. So Tristan, why don't you give us, because I mean we've met, but just give us an overview of what got you into this part, a bit of an overview of who you are. And I always love to understand where this journey to with Hasty and now Cloud Factory, where it all started. Was it by chance? Was it a passion? Had it been something you're into from a young age? We'd love to know your story, man.
Thanks, Tom. Thanks for the opportunity. I'm South African. You might tell from the accent as we're going through. My German wife imported me to Berlin when in 2015, where I did my master's. I did an MBA here in Berlin. And after the MBA, I got sucked into the startup world, especially in Berlin. It's an interesting spot to be. And we were working, in the end, I was working in German manufacturing. We were in an incubator, which was funded by Fiesmann, which is one of the heating manufacturers in Germany, one of these family-owned businesses. And we had this mandate, which was to do design thinking approaches in the factory floor. So there we were, steel cap boots, high visibility jackets on the factory floor, working to define problematics. And we sort of lived by that mantra of, if you have an hour to save the planet, spend 59 minutes defining the problem and 1 minute building the solution. So really, like, it was a lot of that, and like just finding problematics to focus on and to work on. We did a bunch of projects, myself, Kostya and Alex, a couple others that are still in the team today. And we ended up kept on running into vision AI or computer vision problems, whether it was asset tracking on the factory floor or quality inspection on the production line. A few others like distributed asset inspection, loading or logistics inspections for deliveries. And there's a lot that you could do at the time with sensors, with cameras, and with neural networks. And technically, these were all potentially solvable problems and really interesting problems to solve. Like the business impact made a lot of sense. Everything sort of mapped. What was hard to do is this whole like move from prototype into production.
Yeah.
That expectation versus reality is like, it's really easy to train a model to do like a thing in theory based off sample data.
Yeah.
To get that to deploy in production and actually work with reality and data shift and all the other things that happens is really, really hard. And it's for us, it was like a tough combination because you got that reality happening, and the result was Costa was spending his evenings and weekends trying to label data, figure out what was going wrong.
Yeah.
And if you've ever met German manufacturers, they're not necessarily the most patient or understanding bunch.
Yeah.
So they were getting quite frustrated with us, like with things not working again. And you see it's snake oil, it doesn't work. It's what you're building nonsense. We're like, no, it will work. It needs to calibrate. And we just had a hard time. So one of the major components there was that most platforms were treating the data that you're training models on and the models themselves as separate entities. There's this whole argument about data-centric versus model-centric. Personally, I don't love the arguments. I understand the reason for the focus on data centricity because it was such a model-centric world before. But you're kind of arguing about, is my left foot or right foot better? Well, you need both to walk.
Yes, a good point, right?
The models are a reflection of the data. Like it's that simple. So for us, instead of having these as separate universes and one's more important than the other one, it's more like, well, let's put them together in a single platform and understand the interplay between them.
Yeah.
So how do you get data to train a model that you can get feedback from the model on what you need to label and use the model to automate as much of the labeling as possible? We're in the world of supervised learning. How do you minimize the amount of supervision required? These are sort of questions we're playing with and trying to answer. And so we built Hasty with this philosophy in mind. So
Yeah.
the long story short is we were clients first, and
Yeah.
we built a software that would have made our world easier.
Yeah.
And then we thought, well, there's got to be more customers out there that are frustrated and trying to get models to work in production and having this issue of expectation doesn't meet reality. So yeah, we decided to start the company around this and spun it out and founded it back in end of 2018, 2019, somewhere there.
Wow. Yeah, that's quick. Because obviously with everything that's happening with Cloud Factory and building it out and really having a solution that's valuable on the marketplace. It's cool. And I noticed on your LinkedIn you call MBA nerd Berlin, check, which is quite a good story. So was that story behind that, or was it something that just something you've always been? What was the story behind it?
Yeah, I think I can be a bit nerdy at times. I'm not very good at moderation, so I'm either all in or all out when it comes to topics. That, and before doing my MBA, I'd spent 2 years teaching scuba diving in Jamaica and living in the Caribbean.
Nice.
I'd done a few other things that was really fun and great life experience.
Yeah.
Not very strong signals on the CV.
Yeah.
So I kind of made the decision, okay, well, I'm going to do the MBA, but I'm going to have to do really well in the MBA so I can signal ability.
Yeah.
To sort of get things back up to where I thought they should have been career-wise, because it was a lot of fun doing what I did in the Caribbean, but I did it postgrad in finance and accounting. Probably not the natural career progression to teaching scuba maker.
I like it.
Making up for that, I guess. Trying to compensate.
Well, I love it, Tristan, because I like see how people get into their roles. Like people always ask me how I get into AI and the world of emerging tech, and I mean it can be a minefield to understand. And I mean I've got the joys that I can talk around various different topics, and I'm very vocal that I'm not the expert, but I am an enthusiast about it. And everyone asks where I came from. I'm like, well, I came back from like a marketing agency that had knowledge like PR and marketing with my background, and here I am running a company that's very focused on market research for AI, cloud, and data, and all as you mentioned, vision AI and computer vision. So it's always fascinating to see how people's life experiences can take them to certain routes. And in your case, took you to Berlin, right? So.
Yeah, I guess also there, I mean, what enabled that, or enables it, I guess, to some degree, is not being afraid to ask stupid questions. I think 100%. That's one thing I've become extremely comfortable with doing, and it's been a critical success factor for me. When we started with the incubator or the company builder, I knew a lot about business, having studied finance and accounting, but I didn't know anything about tech. That was about 2016, and within the space of 3 or 4 years, was able to get fairly up to speed to understand where technology could work by really asking really dumb questions, like what is a pull request? What's the difference between front end and back end? And it's like a trivial question. And then you hear very experienced tech people debate the answer to these questions, and you think, oh, not such a trivial question after all. And then you get informed a bit, and try and be a student in life and get a little bit wiser about things. And so I think one thing served me well in that, it's just not being afraid to ask really dumb questions. It's really required.
Yeah, I love that, Tristan. It's very similar to me. I feel it's very similar area, because obviously getting into it, I had to ask. I mean, I remember working in engineering, and all of a sudden in the marketing department, and I just thought, this is an area I have not dealt in before. Like, how do I get up to marketing, and where precision's an absolute must, and being ISO licensed or authorized and accredited, and having all these different things. It was it really is that willingness to think, okay, well, what? And I think big people, like I read that book on Elon Musk, like to pick him out, and he says like using abbreviations and trying to be smart. He's like, it's just a stupid way of working, because you're just stopping someone that might have the solution, but because you're talking in a sense where they don't understand it, and you're not displaying it, and quite a bit separate to your point, but it can actually slow down processes. Like, it's like, why do we talk in this manner if just say what you mean and ask those kind of questions at a basic level? Because if you strip it very back down to basics, I mean, they always say the best businesses are born off simplicity, by asking the very basic questions, and asking those ones that certain people that very expertise might think are dumb, but actually are the kind of critical questions. So I like that kind of thinking.
Yeah, no, absolutely. I couldn't agree with that last statement more. This first principles thinking is actually really hard to do, which is why I think most people tend to avoid it. It's quite easy to be a little bit lazy, just throw an acronym at something, and it tends to solve some problems. But misapplication of things is definitely a problem at that stage. So we tend to try and eat, sleep, and drink that, simple
I love
language and first principle thinking.
Yeah, I love that. So tell me then, so people who obviously with machine vision and with computer vision and it's a massive world. Like I saw it very early on, early on in my career when I look back and I was like, oh, that's like that was a use case and that was an implementation of it being used, whether it's on manufacturing lines or production lines or whatever it might be, or spotting defects, however you can different. But maybe someone who's joining that is not as understanding in this area. How would you define, or not define, how would you explain computer vision and vision AI? How would you say this is what to look out for? These are the benefits, and this is kind of how it can help you in your day-to-day.
Yeah, great question. There's a few components there, so I'm going to break it down one step at a time, if you don't mind.
Yeah, of course.
We've got this proliferation of cameras, and we can think of a futuristic world where humans live symbiotically with machines, right? So if it's supporting decision making or actually actively helping you, exoskeletons or the like, you need to teach a machine to see the world the same way we see the world, right?
Yeah.
So it's not only knowing that it's a car, but the context of the car is also relevant. And at some stage, you need to feed this information at least the first time or once, so that machine can understand what that is and agree with you, or there's some sort of agreement about the subject matter.
Yeah.
And so computer vision AI is then training the machine to do this with neural networks. And in this case, it's supervised learning. And the supervised part means that you're marking images up and explicitly telling a machine, this is X, Y, Z. So this is, for example, a car, it is red. And then you show it more cars that are red. And it says, those are red cars. Then it says, this is a red car. And you say, no, that's a yellow car. And then you have to correct that, etc. And you build on this and you layer in complexity. And you use this as ground truth or training data. The training data is called ground truth data. So the machine learning model knows that's what's exactly correct, and it tries to match to what it knows to be correct.
Yeah.
So that's the vision AI part. The how to spot opportunities or what to look out for. I think it's most interesting to look at this in a sort of enterprise or corporate setting. We go far beyond manufacturing in this day and age. We work a lot in agriculture, metallurgy, pharmaceuticals. If you have experts in your company that are looking at things to make an assessment and an informed opinion based on visual information, 9 times out of 10, you can teach a neural network to do the same thing.
Yeah.
So if it's inspecting power stations to understand how to repair those, or if it's inspecting a crash site for a vehicle to understand what's the actual damage to the vehicle and how the crash happened, if it is navigating how to fly a drone, these are all things where you're making decisions based on visual information, and you'll have experts in your company that do this and that look at that information. The benefit one has with neural networks, and why you might want to try to train a neural network to at least aid with that task, is a few-fold. One of them is actually just to standardize things, right? So if we take the agriculture sector and you say, okay, well, in the agriculture sector, we have grades of fruit. I know it's a big problem in India, for example, that how fruit is graded in the different regions is very biased. So if you're a small-time farmer, your negotiation power is relatively low. You might think you have grade A apples, and in fact, the person says you have grade C apples, and there's nothing you can do about it. You get paid for grade C apples, which is relatively unfair. So if you want to standardize this and say we've got a neural network that is standardized and it can objectively say what grade an apple it is, you have an opportunity there to establish some form of fairness, right? Or some form of, this is a reliable reference of what we believe certain things to be. So in a repair or a rust case, you can say this is a widget that requires repair. And you can use that between your experts to establish a consensus between the experts, so that even the experts within a company would all agree, okay, that is the thing that needs to be repaired, which is very often not the case. So it allows companies to establish baseline principles that they can then scale. The other side of this is that they don't fatigue and they can do things a lot faster. So it's not about whether or not a neural network can do, for example, inspection of blood more accurately than a doctor.
Yeah.
It can view 10,000 samples in a fraction of the time the doctor could, and float the likely candidates that need an adjudicator to the doctor, and the doctor can then be the adjudicator. So it means that you can make an assessment on diseases on a bigger sample of data from the body as opposed to a small sample, right?
Yeah.
Which gives a better decision in the end. So it's these kinds of opportunities that one's looking for in a business, where typically your KPI is more reliability, better standardization, and no fatigue.
Yeah, it's huge, isn't it? Like when you say, Tristan, like the big thing I always think is getting examples and getting case studies or use cases. And what you mentioned there, like whether it's in food or medicine or engineering or transport or looking at different roads, it's just nuts. Like how many things it can be applied to, and almost makes you think like how important vision is to people, like to be able to see with our own eyes. Like, so it's really cool to see where it's going. Have you got like any areas that you've seen so far, Tristan, that have really amazed you and how vision and computer vision is being used in the world? Like that one you said on apples, I would never think of that. Like you'd never think of like, it amazes me how we all have food from around the world on our table within seconds. Now you can place an order and the next day it will be at your front doorstep. And to think like all the processes that are put in place to make sure it's being watered, to make sure it's being like grown at the right time, and it's bizarre.
Yeah, some of the like the sort of more mainstream, if you will, applications that we see that are exciting are precision farming, crop yield estimation, pest detection, disease detection. You know, in the future, crops won't blanket spray a field. I mean, crop sprayers won't blanket spray a field; they just spray the weeds. You just need to train a neural network to know where the weeds are, right? Or you won't spray for pests throughout the season. You'll do it just when the pests are there, and you can tell when they're there. If you're using vision, those are cool applications. There's a lot happening in disaster management and relief. You know, what's happened in Turkey recently, for example, we know and are working with 2 teams that went there. To go and aid there. So there's a lot. Those are cool. There's waste detection and waste management. Just like restaurant waste, filming it, figuring out, okay, are we buying too many apples because we keep throwing them out? You know, that's a good one. We've got another team that's doing, they check that the doctors and nurses clean their hands properly before surgeries. So these are like some applications that are relatively in the mainstream, like the weird and wonderful ones we've seen. We had somebody doing penguin migration patterns. To understand the effects of global warming on penguin migration. That was unexpected,
cool,
a very cool one to see. We had one
doing. I need to watch the new David Attenborough series. So I love all that kind of stuff. Seeing how that happens as well. Go on, man. Sorry.
We had one which was they were looking at illegal mining in the Amazon jungle. And then another one which was quite strange is somebody was doing a net nanny for animated pornography. So if your child's sitting watching on YouTube anime or manga or whatever it is, they don't get censored content that they shouldn't be seeing, right? So it's like a net nanny for like hentai porn. That was an unexpected one. So I mean, if you look at the spectrum of things that people are doing in Hasty, it's very, very broad spectrum. So it kind of pays tribute to it's like humans helping machines see the world.
I love it.
Well,
it's like how, like you said, the waste management one really struck me, Tristan, because like I saw on BBC News earlier today with the riots that are happening in Paris, for example. So whether you agree or don't agree, I don't care. But like the impact it's had is massive, because I read that 7,000 tons of rubbish and garbage just in Paris alone has piled up on the streets, and they're trying to figure out how to get rid of it, because all or a good number of people that work in the waste management and in the I forget the name, but making sure it's disposed of, have gone on strike because of it. And you think that's 7,000 tons. That's a lot of waste just in one city to that compound, and you've got to keep up with the rate of how much you're churning out anyway to start figuring out systems. Like, is that a way where computer vision helps those kind of people, or I'm sure it is somewhere, but maybe how, or what's that kind of process look like, using that as an example?
Yeah, great question. We're actually working with a company that does this. So there's one of the companies, one of our platform users has built a neural network that uses camera feeds. So they're working with the municipalities in the Netherlands.
Yeah.
It's a Dutch-based company. And they have various sources of camera feeds. So they've got like these robotic vacuum cleaners that go through the streets and clean things up. That's one source. And then there's some static camera systems that they have access to as well. And they use this to identify areas that need to be cleaned. So you've got this system that automatically says, okay, there's glass bottles that are broken over there. Something needs to go and clean that. There's a bunch of garbage bags that have been torn open by a dog over there. Something needs to go and clean up this. And so they know the hotspots that they need to go and clean. So you're not sending a cleaner to an area that's already clean. You're sending them to the areas that need to be cleaned. So it's just about efficiency. It's like this salesman's dilemma, but for people cleaning the streets. So basically your ability to do that with, I think those resources are already quite strained. Now you're just making sure that they're doing what needs to be done, and none of their time is wasted frivolously. So like that's a very good and very solid use case for computer vision. It's just identifying where the problem is. And the degree.
Yeah. Well, that's it, isn't it? It's like how much of a problem is it? And I always think like how much of a problem can it compound into if we don't deal with it now head on, right?
Yeah, it's also quite useful, I can imagine, in many cases, to know the problem before you leave. So if you can get a photograph of something that needs to be repaired, and from this, or at least information of what's broken, or what needs to be cleaned, you can arrive equipped.
Yeah.
And that extends beyond cleaning the streets, right? I mean, this can go to any form of repair or maintenance gig.
Yeah, whatever it might be in. And so methods of capturing this information. So you look at it, all the examples you gave, which were great. And I'm going to have a guess here that in medical, it might be more through robotics if they're doing surgery, or through cameras that are placed on it. But then there's also drones, right? And there's like robotics. I saw like Serve Robotics, for example, they're serving burritos and fast food and all sorts of things. And they're a great company. We spoke to them, I think, about 9 months ago. You'll have to fact check me on that, but it was some time ago. And they were just really starting to gear up towards that kind of area. And they've focused on fast food because in a local area, obviously it makes much more sense to send around a small little capsule that's secured compared to driving a car around that gives off emissions and might take ages to get there or whatever else. So what are the different methods? Are those all of them? How can people capture this kind of information?
I think what's driving the proliferation of vision AI at the moment is there's a few things that have come together. There's a few components. Drones is definitely one of them, and specifically here, drones with a longer range. The ranges of these are getting pretty good, even for agriculture. So we work with some agriculture companies where they weren't using drones up until recently because they just couldn't get far enough. They'd have to put like 17 charging stations in a farm, which you're not going to do. But now they don't need to do that anymore. So the range in these is getting good enough to be able to serve a farm. So that's an important one. The processors themselves are getting better and better. GPUs are just CPUs are getting better at doing this. And then there's the XPU, which is the new processor, which is supposed to be a hybrid between the two. Even we've run models. Well, I'll get to that. So processors themselves are getting good, lightweight enough, low energy enough to be able to do this in an IoT world. Low energy is an important component. The models themselves are getting better. Architectures are getting better and better and more efficient. We were one of the breakthrough teams to run an instance segmentation model on an ARM processor like 4 years ago. One of the first to do this in a commercial setting. And that was very impressive then. It's probably less impressive now. It's like the standard to be able to do this nowadays. So point being is you just got bigger and better models, or more powerful models on better processors, which are smaller, that are able to do things. And I guess the last component there is, the cameras themselves. Thanks to smartphones, the cost of like these little sensors here are just so cheap now.
Stick them in.
Yeah, in the past where you probably would have looked for something else as a sensor to do something, it's just like, well, camera's so cheap now, you might as well use it. And they're prolific. I mean, the stats and the number of cameras and sensors that are being produced and available and the cost are astronomical, which just means it's very easy nowadays to picture the planets or to capture images. But these few things are 5G, another big component, just being able to pipe stuff. You probably don't want to train or do too much on an edge device. You want to be able to pipe that somewhere and do your inference somewhere and then pipe the result back. So 5G is also an important component for that. So they all come out in the last 4 or 5 years. And what not come out, but like improved, made massive strides in the last 4 or 5 years at least. Let's say that. And come together to make this extremely economically viable. You can now prototype something that's capturing an image and making inference for probably a fraction of the cost of what you could even 4 years ago or 3 years ago.
It's nuts, isn't it? It's like SpaceX, like whether you agree with it or not, the reason it's so popular is because it's commercialized space travel. Like now all the big companies are looking at ways of getting up there. Like you've got bloody Virgin with trying to do Galactic, and like to your point, and you've got Blue Origin and everything. Which is a little bit off topic, but it's the way of just how the past 2-3 years have just been explosive in getting all this new technology. And key thing, right, Tristan, faster. Like you can just get it so quick. Like it's the relays and the feedback time is just, even if it's not affordable for everyone just yet, I reckon it will be like more and more affordable as 5-10 years on, because of the compound rate we're moving at. It's just how quickly I'd imagine you can give customers or partners or whoever it might be, like with the relief crisis, that kind of feedback loop of being like, now you can get on the ground and actually sort situations quicker. It's nuts.
Well, this is the migration, right, from invention to innovation. Like it's technically feasible to do a lot of stuff. It's been technically feasible to do a lot of stuff for a while. Not economically viable though. Right. And you need a few things there. I think of some of the things I left out of the components that are coming in is then also people and process. I think I said it earlier, that to train a model is relatively easy. To implement a system that can see something and learn on the job and take feedback from reality and bring that back into the training environments and learn from it, so to update the model and then therefore understand more and have that virtuous cycle. We'd call it the data flywheel. To implement the data flywheel in production and have the system be smooth and spinning smoothly and working well is extremely non-trivial, and there was no industry best practice for this, right? I mean, we're still trying to get it right. Tesla released a statement a couple of months ago saying that they're improving their models by 40% by selecting the right data and cleaning it up properly. It's like, okay, well, we're still trying to figure out how to select the right data, and there's lots of methods to do this. But there's many ways to break that problem down, and then labeling it accurately and clean it up properly. Well, there's also a lot of methods on how to do that. And, we do both in Hasty, and we do it very actively, but we're still establishing industry best practice to do this repeatably and reliably. So those processes are improving significantly, but also have a long way to go. And then the people, it takes a village. There's the people required to create the training data. Cloud Factory obviously is well aware of that. It takes a lot of people to build the models, to build the infrastructure that you're building things on top. But it also takes a strong understanding of people to understand how to use it. On our client side, it's things like Vision AI project manager or product manager is a new title in enterprises these days, but we're starting to see it more and more. And you need someone like that can have empathy and say, okay, well, we have our subject matter experts that know what they're looking at over there. And these are guys that have been working in the industry for 30 years and they understand something. And there's probably 4 people in the world that know what they know. It's in their brain and they're really experts in that. And then we got to get the tech people here that understand the machine learning models and understand that you have to be explicit about false positives and false negatives. Like you also need to show the thing what you're not wanting to look at is as important as showing it what you do want to look at. And we've got to put them together in a room where they can find it out and establish where the solution actually should be, and then how to engage with teams like us to get us to help them along the way. It's like these kinds of people, product, process, tech, all need to come together, and they are. I mean, there's massive strides there, but that's where we've seen a lot of evolution.
I love that saying as well. It takes a village, because the team at Expert AI, they said they obviously deal in NLP and those kind of situations and contextual data. But looking at it, and they had a very similar view. And it's also nuts, because like that's how things are possible, right? Like you mentioned Tesla, and they mentioned the 1st of March, was it, a couple of weeks ago, that they are planning to reduce costs by half again, like costs on there, which obviously it's nuts, like how you can do it. But once you understand the problem, and I think that's such a good point that you made, Tristan, because Google X faced the same problem. There's a great book for anyone listening called How to Think Like a Rocket Scientist. It's not too hard to read, and it gives lots of different options and lots of different use cases of how people don't properly think of their roadmap or think of their execution. So Google X is the moonshot factory, and they've had all sorts of wild ideas, like releasing balloons up into space, and that can relay data. And I don't know, read it for yourself. There's a lot of crazy ideas that they have there. But they were saying they can't get anything to market, because when they try to sell it to someone, they're like, we don't have a clue what you're trying to sell us. Like you're speaking too technical. Like what end benefit? And they're like, well, it can do all this. And it's like similar to that point earlier. And it's similar to what you're saying. Like you need that village to be able to say, okay, well, these are the benefits, but this is the impact it's going to have for you. It's crazy how we get so caught up, right?
Yeah, I think it's also how people consume this technology is evolving. When it first came out, there's a lot of companies in the market saying, just get the thing to work. We want Vision AI, but we just want to buy a model that works. Like, I don't want to have to label data or train models. Just find me a service provider that can get this thing, and we can deploy it, and it works, right?
Yeah.
So, well, you can do that, probably for relatively simple tasks. If it's doing something vaguely complicated or vaguely meaningful that's going to shift the status quo, you probably want to spend a little bit more time to get more empathy with it. That doesn't mean you need to do what Tesla's done and build an army of machine learning engineers that build their own tooling, et cetera, et cetera. They did this because the tooling didn't exist when they started. The tooling does exist now, so what you need is a couple of people that can project manage this thing and run it effectively and efficiently.
Yeah.
But if there's no one on your side that's got that sort of empathy, and you're just expecting to consume this like a customer, what you can't do and what you lose the ability to do is embed your domain expertise in the neural network. So the sort of the understanding now is like companies need to bring their domain expertise to a partner, and then go through a process of embedding their subject matter expertise, what makes them so good in the market, into that neural network, and then pass that value onto the customer. Right, this is the end goal. That's why your customer is going to pay for it, is because whatever you create now has got your expertise embedded in it, and that's what makes it so great and such a joy to use, right?
Yeah, I completely agree. So it's nuts. You're kind of just taking me away of how crazy it is and what you can achieve, and like what the thinking behind it, Tristan, is to grow those kind of areas and to build that kind of in. Would you have suggestions for where people can start, Tristan? Like what they can do to consider what the right angle is of using Vision AI in their business? Or like, is there a roadmap you've taken people through, or you've seen that successful to implement this kind of technology in their business? And if they need to, like sometimes people implement stuff and they don't need it yet. It's like you don't, like I say all the time with RPA, and they bought a shiny tool because they're like, oh, we can use it. And I'm like, do you have anyone that can use it in the business? Do you know how to use it? And you've gone and spent all this money on licensing and from one of the Trifecta UiPath or someone. And it's like, well, what results are you going to get? Because you've got RPA, but how are you going to use it? And it's, to your point, and to my point, having that strategy and having that roadmap. What would you advise, or what's the kind of roadmap you've seen before that works?
Yeah, so maybe just if I can break down in two phases. You had this evolution in the market of how people used to sell things. It used to be like advanced manufactured goods, like you make just really good products.
Yeah.
Then it was products supported by a very good service support plan, right? So it's, you don't just sell the thing, you sell the support with it or the servicing with it, so that it's always working reliably. Yeah. Then you had a shift from there to complex service solutions, as they call it, or power by the hour, or whatever it is. So you're trying to more and more ingrain your expertise into a product. So you may, for example, in the past sold a tractor. Then you sold a tractor with the service plan behind the tractor, that you're always looking after this tractor. Now you're selling a tractor with functionality, which is being able to identify weeds. Or being able to drive in a straight line or drive itself, whatever it is. It's doing more and more of the service component. You're handling the services that you used to give into the hardware, embedding it into the hardware so that you can pass it on to the customer and power these power by the hour type business models.
Yeah.
So that's sort of like the macroeconomic trend around a lot of this drive, if you will. Vision AI is a very good enabling technology to do that, but without getting sort of too up in the air and thinking about this, it's a very good type of technology where you can layer in functionality.
Yeah.
It's small stepping stones. If autonomous driving, for example, you don't go from 0 to autonomous driving overnight.
Yeah.
You probably first want to start with like distance, following distance control to just see how far you are from the vehicle in front of you and keep that at a safe following distance. Small function, small feature. It does something. It's meaningful to the user. It provides value. I don't have to worry so much about being on the brake all the time. I can have a bit more peace of mind. I'm in a safer vehicle, less likely to rear in the car in front of me. Right? There's a lot. Just that. That's all you need to do. So don't try and boil the ocean from the first iteration. Understand that you're going to do this, and then when you get to a point, it's like, okay, we're now able to see the car in front of me. What's the next stepwise motion? And you can layer in your competencies step by step, one step at a time. This is a great type of technology to do this. And we see this very often. Like, this is very often the approach teams take, and you end up with like one model that does one thing, and then two models that do two things, and then you get a model that selects between the models, and at some stage you end up with like a conglomerate of models that do things that are quite sophisticated and meaningful. But you need to start with the one model that does one thing. So keep it simple. Are you looking at information that is relevant? Do you need to, based on the thing that you look at, make a decision? Could you get a camera there to look at that thing? Can you then get that camera into a place where it can be inferenced on a hardware? Yes. Okay, well, then we can start. That's step one. But I think also break it down to first principles in the sense that make sure that your step one is giving value to the customer. This following distance has got a clear value. It's stopping me from rearing a good car. I have a safer vehicle and I have better peace of mind. Will I pay for it? Yes. So make sure you answer these questions. Is there a problem you're solving for the customer? Is it meaningful? Will they pay for it? Yes. Okay. Then think about the technology. A lot of companies tend to do it the other way around. Like, you want to build tech, so you build tech and then you build a hammer. And once you built a hammer, everything in the world looks like a nail. And then you're like, well, no one wants to buy our hammer. So, you started at the tech. You didn't start at the problem. You just start with the problem first.
Yeah. Well, it's always, whenever I hear businesses that are really explosive or read about them or listen to people, it's always just, I had this problem and it kept annoying me. And it's like, then I figured out a solution and technology helped me get there quicker. It's never like, well, I had this cool piece of tech and I didn't know what to do, but I thought, why not? Like, I've never heard a story or a big successful company turn a business into that kind of giant by that kind of strategy you just mentioned. So it's a really good point.
I mean, the guys that built Slack have something like this, where they're trying to build, I think it was the third attempt, they were trying to build a metaverse, essentially, something like it.
Yeah.
Like this massive open gaming thing that they were trying to build, and they stumbled onto the idea of Slack kind of by mistake.
Yeah.
So not exactly that I was trying to just play around with this tech, but I guess the problem that they were solving there is that they're just communicating poorly between the team. So again, it does boil down to a problem. Like, help them communicate individually or between the team members first.
Yeah.
But yeah, it's a good point. You have to start with the problem in mind. Fall in love with the problem, not the solution. It's really hard to do, especially when you've spent 4 or 5 years building a solution. It's like, don't fall in love with this thing that you bled and sweat for. Easier said than done.
Well, I always think try and stick to the problem, and if certain things change around the business, the model, it can change. Like, it doesn't matter as long as you're getting to the core root cause, as some people like to say, of why it's a problem. I mean, every time I go out, Tristan, I always try and think, like, what about my day-to-day annoys me? Like, what part of it where I think that could be quicker? And I'm like, if you follow that advice, one day I reckon, like, there's certain things I've spotted in restaurants or like doing my house insurance and all these different things. And I think that'd be a great business. It's just like, or like piping on the side of my house to stop the water leak, whatever it might be. It's if you think of that mindset, it's just businesses come out of nowhere, man. So a really good way of thinking.
Actually, I try to kill Hasty a bunch of times.
Really?
So let me qualify the statement.
Yeah.
I think when you build a startup, you have processes where you're speaking to investors and you're speaking to potential customers, and some conversations go well, many don't. You got to get used to rejection. High rejection rates just part of the gig. And so you come back, and eventually at some stages they'll be like, okay guys, what we're doing is not meaningful. It's not changing the status quo. It's not going to change the planet. Like, are we doing the right thing? And we'd come back, and as a founder team or a leadership team or whoever it is, actually generally often even the whole team, we'd sit and break down and say, okay, let's break this down to basic principles. Does the problem still exist? Is the problem solvable? Are people willing to pay for this? And you really build it out that way. And then you end the conversation, you say, okay, no, we are actually doing it, doing the right thing. We are doing it for the right reasons. But every time we went through one of these iterations of me trying to kill the company, it actually made the story of why the company exists more robust and better and more fleshed out. And then the next time you speak to a customer, you become more eloquent on the value prop and what you're trying to do. So it was a good balance in the founder team. I was often the skeptic and saying, like, are we sure we're doing what we're meant to be doing? And then Kostya, who was, he's the technical brain. So Kostya, Alex, and myself were the three co-founders. Kostya was the technical genius, and Alex and I were holding on to his coattails. But he was the one that sort of stayed fast in the conversation and said, no, we are doing the right thing. And the reason why we are is because of X, Y, and Z. So it was good to have like the good cop, bad cop from that perspective, the pessimist, the optimist, the realist, the three of us.
It's good. No, that's a good duo. It's or three people. It's great to have that kind of bounce of characters and ideas and the kind of clash as well. And I tell you what, I've seen
when it works,
yeah, I don't know if you've seen it, Tristan, but if you have Netflix, it's a great series called The Playlist, and it's focused on how Spotify and it's just nuts. Like the one on the engineer, it just blew my mind. Like I told one of my mates, he's one of my best mates that works at Experian. I told him about it, and I was like, the episode on the engineer or the technical guy, I was like, it's just mind-boggling. Like obviously he gets in a massive argument with it, not give too much away, but they come to this solution that's obviously or what seems to be, I don't know how accurate it is. It seems pretty accurate to the solution of what people have on nearly everyone's mobile phones today to use Spotify. It's but it wouldn't have happened, like you said, without that clash of characteristics, which I think is a really important part for any business.
Yeah, I think you can define good teams by how well they fight together. I mean, anyone can get on. It's easy to get on. But if you're changing the status quo, you should be challenging the status quo. And that is a challenging thing to do.
Yeah.
So you're gonna fight, and you need to fight. Like I really don't mind fighting in the workplace. If people fight with each other, it means they care.
Yeah.
What I really hate is apathy. It's like, who cares,
Yeah.
That sucks. And it's something I can't deal with. But fighting's great. Like that's how you get to a better solution. And one should we actually after a fight would be, thank you for caring enough to fight with me. That's like a sentence we would say to each other.
Yeah.
It's hard at times and it's exhausting at times, and at times oh god, we have to do this again. It's not always fun, but the result was always better. It was always better. And I think it's coming back on topic. Drifted a bit. It's the same fight that needs to happen between subject matter experts and machine learning engineers. It's the same thing.
Right.
Subject matter experts saying, well, the neural network needs to do X, Y, and Z. The machine learning engineer says, well, it can't do X, Y, and Z because that's not how they learn. It's like, well, then it needs to do this. And then it's like, well, if it needs to do this, then it needs to do that. And it's like, that is the conversation you need to be having in your company now.
Yeah.
You need to get those two in a room and they need to thrash it out, because it is two different perspectives, two different domains, two different ways of looking at things. And that conflict is really the healthy conflict you need to draw meaningful results, to capture your subject matter expertise into a neural network. So you need that fight.
Yeah, I love it.
Come back to topic.
I agree with it, because there's so many examples of successful companies. Like with Microsoft, everyone said Bill Gates would be at your throat if he didn't get what he wanted or how he wanted it, and you'd have to battle with a realistic, like, is it possible? Happening with Steve Jobs, like if you read Creativity Inc. in Pixar and in Apple, and he always said if you stood up to him, he actually loved you. Like it was a constant theme. If you speak to any people that were involved in the C-suite, if they kind of really stood their ground and said, no, you're wrong, like, and this is why you're wrong, and didn't back down, he admired them, and he really showed that they had the passion and more recently that I've learned about, like the Lamborghini Ferrari whole episode, where the Lamborghini guy fell out of his engineering team because he was like, why the hell can't you build me an engine for a car? And obviously it's like, we build tractors. Like, how the hell are we supposed to build a car overnight? And he's just, I don't care. Like, this is how we're going to do it. And it's those clashes that really show the passion in people of what they're, like you said, with the machine learning engineers compared against someone else. So, I mean, I could talk to you for days on that angle, Tristan, because I really believe in it. It's healthy competition, healthy arguments, or healthy fighting.
Yeah, it's the origin of the Amazon 6-pager. Was write a 6-pager and defend it. Like, they have to defend it like you're defending a thesis. And it's, you've had the good, well, at least the good prep work of being able to structure your thoughts, which hopefully you can defend it in a more meaningful way. But it's important.
Yeah, 100%. So to bring it back a little bit more on topic before we get inside that, one thing I did want to ask is, how have you seen it in your time at the moment, especially with moving into Cloud Factory? And obviously we did that webinar with what you do with drone inspection. I think it's terrific. And I mean, I met your team, and you know, what you and the team are doing is brilliant with Cloud Factory. And now with what you built at Hasty. But I'd love to know, separate to that, how have you seen the world of ML change, of machine learning change? Sorry, how, and we mentioned it a few topics, but I don't know if there's something like, obviously ChatGPT, which I'm really trying to refrain from talking about at the moment. Plenty of other conversations going on, but I mean, that's happened overnight, even though the technology has been around since like 2017 or something. But how have you seen machine learning change, and how have you seen its applications to vision change? Has there been any kind of, and maybe I'll ask that one afterwards, but back for first, how have there been any major advancements that you've seen, Tristan?
Yeah, definitely. What have we seen change? I think an understanding on how to work with the technology in general on the client side is constantly improving, and that's extremely encouraging. A lot of breakthroughs have come semi-supervised learning from what you haven't labeled as well as what you have labeled. So you got teacher-student models there it gives you an extra lift. So we've got that in the platform as well. That's had some cool results. Active learning. We did a research on active learning last year and got an approach verified, which helps you reliably identify inferences or images that the model is not performing well on. It's not a trivial task. There's a lot of rudimentary ways to do this. There's a lot of very complicated ways to do this. I think we found a good balance between a very simple approach but very powerful approach to say, okay, where are things not working? Because your model's not going to perform. Like Mike Tyson said, everyone's got a strategy until they get hit in the mouth. Your model's going to get hit in the mouth, right? Like it's going, it by definition has to. It's been trained on a sample of data, and now it's working on population. So what do you do when you get hit in the mouth? Active learning is a very good answer to that question, as well as, we ran active learning. We ran it on Coco dataset, and we could get the same model performance on 30% of the data by just training a model on the right data. So selecting the right data, there's a lot of work that's been happening there. It's one of the things Tesla's recently done, and where they got their 40% lift on. Selecting the right data to label. And, I think in the past, a lot of teams would just get 2 million images, brute force it, and just label 2 million images. And now you got your 2 million images and train on that. And now it's like, well, no. Of the 2 million, let's just first focus on the first 200,000 that are meaningful. And then from there, with the next 100,000 or 50,000 that are meaningful, and then you work in this motion until your returns, you'll have diminishing returns. So using active learning the right way to select the right data is important, and it's getting done better and better. And that's creating a significant lift. There's a few teams that are doing that well. How to clean up labeled data. Cloud Factory is one of the best in the world in terms of, depends on who you ask, but we're up there with one of the best annotation teams in the world, I'd say, if not the best. In terms of quality. And even then, there's humans doing things which mistakes do sneak through, and you'll see some error rate in what's been labeled. But we see up to 20% error rate on labeled data. It's like you're feeding a model 20% incorrect information and you think it's going to work. I'm not in Cloud Factory. Sorry, you don't see 20% in Cloud Factory, but
Yeah.
you know, before we were acquired by Cloud Factory, we worked with quite a few annotation teams.
Yeah.
There are some teams that, you know, close to 100%, but to weed that out is hard to do. We've got a process that can do that, and there's some teams that are on our heels in terms of that as well.
Yeah.
But super important to, like, if you just have a good, like, just knowing that you're standing on a good ground truth data set means a lot. And there's breakthroughs in being able to establish and do that. So semi-supervised learning has been big. That there's a few things, accelerations and processes, and a few other things that are there, but it's very deep in the model and technical. So I won't dive into that.
Yeah. So maybe what I'd like to ask as well, when you've seen companies doing this, so whether they're a startup or they're a larger SME or they're more towards a publicly traded or Fortune 500, whatever it might be, I guess how I want to frame my question is, and you might need to tell me here, but when you've got something, when they've done a project and it hasn't worked, or they're looking where to get started and they're looking to retrace their steps, Tristan, and think, how can we make this right? What have you seen that's worked on kind of thinking, okay, let's take a step back and think about why we got this wrong? Because mistakes do happen. They're always going to happen. But startups especially, and I'll speak as one of them, you've got founders that make very quick decisions that aren't the right decisions. To implement things, at least in my personal experience. How would you walk them through, or what would you try and advise them to do to step back if it's with data annotation, with Cloud Factory, or what you're doing at Hasty, to kind of say, look, just stop, rethink? Or maybe that's not the method. What would you suggest, Tristan?
You break up the end of the question, but I think I got the question. So it's a great question. So it's actually one of the reasons we built the tool the way we have. So the whole philosophy of Hasty is that you bring the model and the data into a single platform and you understand the interplay between the two.
Yeah.
One of the major benefits you get from this is that you are very quickly able to understand how the model understands how you label something. Is your taxonomy correct? So just a simple example of taxonomy. We spoke to the team at Planet, the satellite company.
Yeah.
And they were saying for projects, on average, they iterate 7 to 9 times on the taxonomy alone. Yeah. Never mind like annotation strategy, just the taxonomy to get it correct. These iterations are like a foregone conclusion. You have to do the iterations. And you know, without having them in the same and having fast feedback loops and having things in the same platform, we saw those iteration times take anywhere between 3 to 7 months.
Yeah.
That looks a lot like waterfall, and it is a lot like waterfall. Now, if you build software or any software solution and you took 7 months to iterate between versions of software, you'd say, yeah, that company is definitely going to fail. That team's definitely going to fail. It's too long to iterate. Yeah. But we're doing it machine learning and wondering why we're failing. Like the failure stats are quite bad, actually. And I think largely for this reason.
Yeah.
So teams that do well do things like work with annotation teams that give them feedback on taxonomy or annotation strategy and say, guys, you might want to combine this into a single label class and use an attribute to distinguish between them instead, because the neural network's seriously struggling to distinguish there. So be comfortable with iteration, be feedback driven, pretend it's software, even though it's data, and it's hard to iterate with data because data is hard. But you need to have that mindset and understand, okay, we're going through an iterative process here. We're going to iterate 12, 15, 20 times, but every time we iterate, we should celebrate because we're one step closer to success, and we have to go through these iterations to be successful. Yeah, your machine learning engineer is making a best guesstimate on things when they start.
Yeah.
And it's not like anyone's got 40 years of experience of thousands of models and projects to do this. Like, they're doing this based on research that they've learned over the last 5, 7, 8 years.
Yeah.
Right. So how are you going to put that responsibility in front of somebody and say you have to get it right first go?
It's not possible. It's impossible, isn't it? You can't. It's just wrong.
No.
You signed up to fail. It's yeah.
You have to understand it's best guesstimate, and your best guesstimate will then improve and step by step, and then you'll get to something that works if you embrace the iterations.
Yeah.
And be comfortable with failure in the beginning, and be comfortable with teething, and plan how you're going to phase things out or in.
Yeah.
Right. I love this. I hate the question where it's like, well, when can we fire the person that we're replacing? Well, you probably should never. And if you're looking to do that as a KPI, it's probably the wrong KPI. It's like, well, how can I make this person more effective in the job? That's the right KPI, and that's the way you need to think about this. It's not a replacement; it's an augmentation. Like there's going to be a symbiotic relationship between the two. It's not a substitution.
Yeah, I always love it as well. I always try and think like when I was in work, and if things weren't going my way, or I wouldn't say underperforming, but if there were things I didn't like, I'd always think, how can I get more passionate about this? Because the more I'm passionate about it, the less work is going to be. And, it's why you find coders coding till 3 or 4 o'clock in the morning on, on a project that they really want to be involved in. And they're sending Slack messages till God knows what times, because the passion's there. And it's thinking, how can I invoke that in a team? And how can I get them back on track, or whatever that might look like, whether that's making it more, something that they care about, an impact, or making it more of a project based, or making it sure. And to your point, I think that speeds them up to where they need to be, or finding the project. And I also like the saying constantly, it's like, what was it, when the guy was Edison inventing the light bulb, and they cracked for the 999th time, and he said no, and someone said, oh, you're never going to do it, and he just said, no, I've just found another way, it's not going to work. And then obviously he invented the light bulb. But it's a really good way of thinking, and I really appreciate that strategy. And final question, Tristan, what do you think about the world of camera use, but with space, and how's that different from drones or using robots that are on the ground? Is there something that you think will be much more explosive? Because you see cameras going up into space and doing wider, more receiving. Is it something that you're familiar with or interested in?
Yeah, I think it's dangerous to focus on the technologies, right?
Yeah.
So the two of their benefits, the imagery you get from space, 7 or 8 channels that they get, right, which can do different things.
Yeah.
Right. It's not you're playing 3-channel RGB. It's 7 channels, and those channels all serve different purposes and are good at different things.
Yeah.
Whereas versus a drone, it's just a different perspective. It's different resolution. I think still with space imagery, your pixels 30 centimeters. Right. So you're not going to spot an insect from space. The 30 centimeters is 1 pixel, square centimeters. So the two image capture approaches are fantastic at solving very different problems. And I don't think it's a trade-off of a one versus the other. That's putting things the wrong way around. It's looking at the tech first and the problem second. I'd say look at the problems first and then get the right tool for the right job. But I think we're almost trying to compare a hammer and a chainsaw. Like they're doing different functions very much.
Yeah, they're designed for different things, which is a great point, because clearly even I make the mistake where I think like, oh, well, you can compare that to that, and it's like, well, they're designed for, like, you can't compare a rom-com against a thriller. It's like they're designed to do different things for you. It's hard to do, like you said, designing one thing which will have one design against something else which is designed for something completely separate. Or comparing people to other people.
Yeah, it's also the nature of the thing. So, satellite image is still image from above, and it gives you a shot in time, whereas drone is a video feed. And they have their pros and cons. The one's dynamic and can serve, for example, you can see things like process. Which might be important depending on the task you're trying to do, right? That's the benefit of video. If you ever wanted to learn to kick the ball like David Beckham, you need to watch a video. You're not going to get this off images, right? But if you wanted to understand the damage of something, video might probably a little bit less relevant there. So it's define the problem type first and work backwards from there, I think, is the advice I'd give on that front.
It's a great way of doing it, though, because it's or a great suggestion, Tristan, because looking at whether it's something that you need as a static image to really investigate it and really get clear on what's happened, and looking at a very slow moving thing compared to watching, as you said, with the Beckham example of watching how they do it and watching various different videos, various different scenarios, to looking at maybe various different images, right? It's a completely different game.
Actually, I can give you an example on this that's quite tangible. We were working with a team recently that they are required to spot it's an airport. They need to spot flying objects around the airport for obvious reasons.
Yeah.
This includes things like drones. And things like drones don't necessarily have to emit signals of what the vessel is or vehicle is and where it is, right? Most things emit signals, but you're not necessarily required to. So they need to both, for redundancy purposes, be able to pick up things on, the normal channels, as well as being able to see things, right?
Yeah.
And there's some weird legal thing that you have to do this to 3 or 4 kilometers. I can't remember exactly the distance, but it's more than 5, well, it's more than 2, and it's less than 10 kilometers in that range. And you need to, with a certain reliability, be able to see these things. At that distance, on a 4K image, a drone is 3 by 2 pixels or 4 by 2 pixels. It's a black smudge.
Yeah.
Right.
Yeah.
On an image, you're never going to be able to tell what that is.
Yeah.
You'll see a black smudge. Is it a plane really far away, or is it a drone a little bit closer? That's a black smudge.
Yeah.
But they need to classify it, and legally they need to classify it. This is like the requirement. It's a legal requirement. So how do you do that? Well, you might be able to use video feed to see the flight pattern. It's like, well, from the flight pattern, we can see it's got this kind of speed, that kind of altitude. It's got these sort of flying characteristics. That flies like a drone, and this flies like a plane that's a bit further away. And you probably could, from that, do that relatively reliably, like over the 90%, do it that way. But it's a good example of like define the problem first, and then look back. Is it image? Is it video? Can we see it from an image? No, we need to look at video, and then from there, you can prototype the solution out.
Yeah, that's awesome, Tristan, because I had no idea. Like, it's one of those areas where even that's why I love doing these, because I get to learn from the best as well, and it's really exciting to see how it's and learn from people that are. That's why I started the whole business, to learn from people that are actually in the trenches and doing the work, and have seen the examples and seen the failures, but the successes. So it's really really good feedback for people joining. And I guess one last question, because I'm conscious of your time and respectful of your time. I want to do another one of these to learn a lot more around these different topics that my mind is racing with. But is there anything that you're excited personally, Tristan, for over the next year or 2 years that you've seen coming in, that you've seen developing, and you kind of just generally, whether it's in the vision and computer vision space, or just generally what we're experiencing at the moment? Obviously, seeing a lot of people experiencing ChatGPT, and people have different views on that. But what about you with different technologies, or what you're working on in Hasty and Cloud Factory? Is there anything that's really getting your grips and really exciting you?
Yeah, but it's not related to like the technical side of things. Like, we're having fun on the tech side, like working with various companies that produce the processes to see what we can do in terms of data mining far more efficiently. And, there's an opportunity of CPU versus GPU to do that in certain ways. And, as I mentioned, active learning, there's a few other things on the tech front which are fun, but sort of zooming out a little bit. When we started Hasty, the statistic, according to research, was that 67% of Vision AI projects fail. Oh. Then the next year, research came out, and that went up to 76%. And then the year after that was 87% of these projects fail. And we just teams just weren't getting it right, and struggling. Then you had the shift from model-centric to data-centric, and that created a lift. And then you've had a few other wins on the back of that. And last year, we saw statistics that, in the face of the recession, like a good 30% of top corporates, or 40% of top corporates, are just doubling down their investment in Vision AI and machine learning technologies. So, and that failure rate has dropped significantly. When we started Hasty, I think I once said to one of the VCs that was grilling me, like, he said, "How would you define success?" And I said, "Well, if we're successful, the failure rate of projects has dropped from 67% to 0%.
Yeah.
More teams are confident that they can use this technology reliably, which means more teams are doing it, and we enable machines to see the world." So the number one KPI I'm tracking is that failure rate, and it's coming down significantly. So that sort of that makes me excited, because it means more and more enterprises will look to use this technology. The invention will become an innovation. We will have the impact that I was hoping we would have on the world when we started Hasty, which is allowing machines to see the world, which means that we enable this exciting future of how humans might live side by side with machines and do all kinds of amazing things. So that drop of that failure rate is one that like almost gets me goosebumps going, because it means that we're getting to a position where, or a place where we can really start seeing this being implemented.
Yeah, man, blows my mind with all kind of stuff that we're going to be seeing over the next 5-10 years. Like, kind of count myself lucky to see what will expand and what will happen. And I mean, similar to you, I'm very optimistic about the future, and I'm always going to hold that view. But it's exciting, like you said. You touched on some great points as well, Tristan. Like the whole process of building a village and making sure that people are in, and what you're doing at Cloud Factory, and some really brilliant use cases. I really appreciate sharing that, and it's been an absolute pleasure to have you on, man.
Thank you for having me. It's been a joy.
Awesome. So everyone joining us, really appreciate it. Tune in for the next one. We're back in a few weeks, and looking forward to having you for the next session we have. Tristan, cheers again, and thanks again for everyone having us.